All right, so this section that you're looking at right here, it's the last one we're going to look at before we go straight for review to your assessment, which is a week from today. All right. The last thing we're going to look at is what's called a radical equation. We all can solve equations. Radical equations, though, have a radical symbol in them. For us, that'll be a square root. It could be a cubed root. That's still a radical expression. It could be a fourth root. It's not going to be for us. It will stay a square root. Okay. But it could be something other than that. So that's why it doesn't say square root equations and why it says radical equations. I hope every person in this room can solve this statement. I hope. How many moves to solve that equation? Logan, how many do you think? 2 moves? Ben, what would the first move be? To subtract 5. But you say subtract 5, and I don't see a subtraction up there anywhere. So why would you subtract? Why, Ben? Yeah. To get rid of what? Okay, so to move something from one side of an equation to another, you must do what? You must do its opposite operation, or what we would call its inverse operation. So if I see addition, I subtract. If I see multiplication, I divide. So if I see a square root, which is what I'm going to see today, how do I undo a square root? I square it. Okay? So if this problem right now were to have a square root over top of one side of it, it is now called a radical equation. Nothing crazy. Okay? The hardest part today is probably going to be deciding when I should square it in order to make it go away. Okay? Or in order to inverse that operation and cancel it out, so to speak. Now, if I did that, if I came in here and I squared both sides of this equation, can you tell me what I'd have? Anybody tell me what I'd have in there? You all should be able to tell me the right side for sure, as long as you got a calculator in your hand, right? That'd be 16 squared. 196. Okay, so 14 squared on the right side is 196. Good. What's the left-hand side going to look like? Okay, it's one option. 9x squared plus 25. 625. Yeah. I got your idea. Do me a favor. You all have if you have a calculator in front of you right now, pick it up. I want you to think of a number in your head. Don't say it, don't type it, don't do anything, just think of a number. All right? In your calculator, type the square root symbol and input whatever number you just said to yourself, whatever it is. Hit enter. You maybe got a whole number if you picked the perfect square. If not, you have a decimal on your screen. Is that correct? Yeah. Without clearing that decimal out, square that answer. What do you get? You get the number you started with, right? Everybody except for Olivia, apparently. All right. You should have gotten right back to whatever number you started with, right? Why is that the case? Why is that the case? Not that they're opposites, but they're inverses of each other. They cancel each other out. So if I started with the number 10 and I took the square root of 10 and I got 3 point something, and then I squared that 3 point something, I'm going to go right back to 10. Okay? What am I trying to say to you? If I have something under a square root and I square it, nothing's going to happen. What am I going to have here? I'm going to have 3x plus 5. Okay? That square root and that square wipe each other out. They're inverses of each other. Okay? So do not change what you see underneath the radical. Does that make sense? They are going to remain the same. And now at this point, can we all solve this? Yeah. Sure. We move the 5, we divide by 3, we got it. Like radical equations aren't hard. The hardest part is going to be for you to decide when you're supposed to square it. Okay? And we'll see a handful of different problems today. And each one's going to look a little bit different. It'll be your job to decide, like, at what point am I supposed to actually complete this option of squaring both sides of the problem? Okay? So that's what we're going to kind of get into today. And like I said, we're going to look at it in a couple different ways here. So, yes, I know I have the same example listed twice. Not sure why. Maybe I should fix that. Thanks. Based off our class from yesterday, looking at that expression, can you tell me which one of those is the correct choice? Number 1, number 2, number 3, or number 4? 1, 2, 3, or 4? Lily, 5's not an option. It's just 1, 2, 3, or 4. Andrew, which one? 8 radical 17. Very good. Should be the second one, right? What allows you to be able to add all 3 of those together, Kyler? The radical? Uh-huh. Are the same each time, right? They're all square roots of 17, so I can take those coefficients of 3, 11, and the negative 6, and I can add those together. And so I do get 8 radical 17. All right, we'll let that one go for today. We are trying to solve radical equations, number 1. And number 2, we're trying to solve them with what are called extraneous solutions. Now, I would assume most of you have probably never heard the word extraneous before. But as you look at the word extraneous, do you see something inside of the word extraneous? You see the word extra. Okay? So somehow we're about to create an extra solution. Like sweet pearl. If we didn't have enough, now we're making extras. That sounds like fun. All right. So we'll talk about that kind of towards the end. You'll see what I mean. You guys already got this piece. You said, if I square both sides, I'll get that square to cancel itself out. So we're gonna take a look at this one here first. If you dropped an object from an unknown height and it took 7 seconds to hit the ground, you could use the equation t equals the square root of h divided by 4 to find the height from which it was dropped. Yes, ma'am? Okay. What just happened there? Oh, okay. Where does the 7 go in this problem? Where's it go? Goes in for the t. So if I rewrote this equation to say 7 was equal to the square root of h divided by 4, how many operations are holding you back from getting the answer to say h equals something? How many things? 2. What are the 2 things? I'll take one of those. The square root is true. There's a square root in there, but you're giving me the inverse of it, right? Yeah. What's the other thing that's taking place? There's a square root in there, and there is division. I've got to make the decision about which one of those I should get rid of first. Got a thought? Listen, worst case scenario, it's 50-50, right? Is it get rid of the square root first, or is it get rid of the 4 first? What's that? Oh, that's not true. We can solve equations by doing the inverse, right? Working backwards. What?
Can you just multiply this 7 equals h?
Say that again?
Just do the opposite. 7 times 4 is 28 equals h.
Okay. No, that's exactly what you want to be thinking about doing. We need to get rid of that 4 before we mess around with that square root of h. How do you get rid of that 4? You multiply it. Okay. All right. So I'm going to multiply both sides of this equation by 4. That is going to cancel on the right side of the equation. It'll cancel those 4s out. On the left side, 7 times 4 is 28. On the right side, I now just have the square root of h. Now that I have the square root, how do you get rid of a square root? You square it. So I'm going to square both sides. So if I square both sides of this equation, when you square a square root, they cancel each other out. You just get h. And on the left-hand side, 784. That's a long fall.
What, I got 74.
Not that bad. The fall's not that bad. It's just the end when you hit the ground. That's the part that's bad. That's right. And you better make them count because they're going to be the last 7 seconds. So you better make them good. What's up?
Why do you have to like do the 4 times 7 and the 4 times the other? So why didn't you just do 7 times 4 from the beginning and square it?
Why couldn't you just do 7 times 4 and square it? Did you know that from the beginning?
Was kind of my initial guess.
Was it? Okay. Well, how about this one? Still a radical equation because it has a variable under the square root. How many things do you need to do in this problem to get h by itself? How many operations are holding down the variable? 8 and how many? 2. What's one of the things that has to change? What's one of the things you got to get away from that h?
Negative 5.
The negative 5, that's one thing that's got to go. What's another thing that's got to go? The radical sign or the square root. So in this case, which one do I move first? So you can't move the 5 in this one.
But can you do
Why not? Hold on one second. Hold your thought for 1 second. Why can I not move the 5?
Isn't it because there's not another one on the other side?
No. Kylie?
If you try to move it, it just make it H.
Oh, that's ultimately what I want. But why can I not move it? Because it's under the radical. Okay? If this square root symbol ended right there, if this part was not there, and it said this, the square root of h minus 5, if it looked like that, now you move the 5 first because it's outside of the radical. How many of you, when you were doing this activity that's posted around the room, we had to stop and ask, did you write this correctly? Is the radical, do you have it written? How far does that top, so to speak, of this, how far does it go? Okay, so it matters by how it's written. And in this case, I can't get to the 5 until I get the square root off of that expression. So how do I get it off of there? I square it. Okay, and at this point, I'm going to square both sides of this. Now, the left side's easy. The square and the square root are inverses. They cancel. It's done. Okay, because if you, whatever, it's an equation. So whatever I do to one side, I got to do to the other. Whether it's add to both sides or multiply to both sides. What's up? Did you have to do that? The other side is 12. How'd you figure that out?
It's the square root, it's just 3 and then 2 squared is 4, so 4 times 2.
Okay.
I got it right this time.
You did. 2 square root of 3 squared really means you have 2 square root of 3 multiplied by itself. We learned yesterday that a value or a coefficient outside of the square root can be multiplied together, so 2 times 2. The insides can also be multiplied together, 3 times 3. So I end up with 4 radical 9. Square root of 9 is 3. So I really have 4 times 3, or I have 12. So this number is a 12. Can you finish solving it at that point? I would surely hope so, right? I hope so. I just add 5 to both sides, and I find out that h is 17. Okay. Well, they're all similar. So here's the next one. How many moves are you going to have to make here? Can you see it? You don't have to know the answer. Can you see how many moves you're going to make? Quinn, tell me one thing that has to move away from that variable of x. The 3. So I got to move the 3. That's one thing that's got to happen. What's another thing? Got to move the square root and
Subtract eight.
got to move the 8. So of those 3 pieces, which one's got to happen first? Which one is it?
The eight,
Why is it the 8?
because it's not
Good. It's not under the radical. So move the 8 to the other side. That shouldn't be hard, right? It says plus 8, so minus 8. Now, x minus 3 under the radical is equal to 7. So do you get rid of the radical next, or do you get rid of the 3 next? It depends on how it's written. Get rid of the radical. So, can you come up with a final answer? If you can, it should be a 2-digit number. Very good. How did you get from here to here?
I-
Squared it? But if you square that side, what do you got to do this side? You got to square both of them. Got to square both sides. That'll be correct as soon as you correctly add those two together. Then it'll be right.
Good job, Logan.
How did you get from here down here? What did you do?
I squared.
If you square this, that side should remain exactly the same. And if you square this side, you also have to square the other side. Where did your square root go? You took it off. You don't get to take the square root off until you square both sides. Yep, so this side is equal to x minus 3. So that should say x minus 3. And now you're going to at this point, because you do not have anything else other than that radical, you can square both sides. Very common to watch people square the side with the radical and just let the other side go. Okay? It happens all the time. When you square a square root, whatever is under the radical does not change. That should stay x minus 3 is now equal to 49. Add the 3 to the other side and get a final answer of 52. A double digit number. I should have been more specific because a lot of you guys came up with a double digit number and were like, hey, I'm good. Right? Because if you don't square the 7, then you end up getting 10. That's a double digit number. You're like, I'm good. I'm good. Yeah. So you got to be careful there. All right. So yes, your final answer here when you add the 3 to the other side should be that x is equal to 52. All right. We'll let that one go. What if it looks like that? You got square roots on both sides. What do you do? Square both sides. What's going to happen?
keep them the same.
Square roots are going to do what? Square roots are going to cancel out, and you're going to be left with what's underneath them. That shouldn't be too difficult to solve, right? Yeah. So because you see it on both sides, both of those square roots would fall off. Exactly. No. No. Yeah, you're fine. Hers was not. I take that back. I think I.
It is right.
No, it's
I
not.
did the steps. I subtracted from that side. I got x.
Look what this says right here. What is that operation?
It's addition right here. So I
Yeah,
added.
why is it addition down there? It's been minus the whole way.
Oh,
Why did it change in your last step?
I don't know. I wasn't paying attention.
Oh,
There.
you take it back.
Yes.
Yes, you are correct. What you got back there, Fish, Ohio? What you got? X equals 8. Very good. right? Okay, so in this scenario here, I can move my variables to one side, I can move my constants to the other, and I'd get an answer of 8. Okay? Not okay? No, not yet? Okay. All right. Let's try this one. See what you come up with. Let you give this one a shot. Just so we're all on the same page, what's going to have to move first? The 12. Good. The 12 is on the side of the variable. It is outside of the square root. So I'm going to move the 12 to the other side first. All right. Once you've got it down to that square root, you're going to want to square both sides. Where are we at?
Right here.
Okay, but if you minus it from this side, you got to minus it from that side. You can't.
Negative.
Okay, so it'd be 6 minus 12. If you do that, that doesn't match what I see right there. You did it. Oh no. What happens when you square a negative number? If you don't use parentheses, you're going to get it wrong each and every time. Each and every day of the week.
Is it just positive of what I had before?
Okay, well, that's a positive.
Hey, listen, if you don't think positive and negative are any different, then I'd like to borrow some money from you and you can pay me back. If you don't think positives and negatives are any different. We all get there? Then what do we do?
Square.
We square both sides. Okay? You guys pick up that calculator, you square a negative number, and it stays negative in your calculator because you don't use parentheses and you don't stop long enough to think. What happens when I square anything? Doesn't matter what it is. If you square it, it's going to become a positive. That is not going to change. So in this case, I end up with 6x equals 36. So I get an answer of 6. How many of you have 6 on your paper? Awesome. If you have 6 on your paper, you're wrong.
Yay!
How many of you, what? How many of you, when you're solving an equation, do that? Honestly. One?
I sometimes.
Listen, if I'm involved in this conversation too, I'm not raising my hand. I don't check my work. And I know a lot of you don't check your work either.
It should
Why don't you check your work?
be. Wait for you to do it.
Well, a lot of you check your work by asking me, am I right? That's how a lot of you check your work. Right? How many of you believe that your work is right in the first place and there's no need to check it?
No.
How many of you are just not motivated enough to check your own work? Okay. Whatever the reason is, here's the deal. When you're working with square roots, you have to check your work, me included. Here's why. This answer isn't right. And I don't think anybody in this room that would get an answer like 6 would think that they're wrong. But if they got an answer like 5.432789, they'd be like, oh, yeah, that's wrong. Oh, yeah, for sure. Right? How many of you, when you get a funky decimal like that, go, oh, screwed up somewhere? But you get a whole number answer, nobody thinks that's wrong, do they? Everybody thinks that's right. Right? We all think it is. What's up?
Why do you solve it and it gives you one number, but the
Excuse me? What did you just say?
Okay, so why do you solve it and you get the wrong answer, but like you solved it correctly?
Okay, so let's, first of all, if I take this number and I plug it back in here, the very first thing I would have to do is 6 times 6, right? That's 36. I take the square root of 36, I get 6, and I add it to 12, and it's equal to 18. And it is not equal to 6.
Okay, but why does it make you solve it for literally no reason?
Okay, so first of all, I didn't solve it for no reason. I didn't know that that was going to happen, right? So, first off, this answer here is incorrect. Okay, that's number one. Number two, in order for this to be correct, what's up? It would have to be 12 plus a negative 6 in order to get 6, right? But that's not possible. You can't take the square root of something and get a negative answer. And that actually showed up right here. We have the square root of 6x is supposed to equal negative 6. But then something happened. I squared the problem. And when I squared it, I automatically turned my answer into a positive. Squaring it is how I removed the square root. But in this case, when I did it, it forced something that was never true. This highlighted statement here could never be true. And it turned it into something that was 6x equals 36. No problem. Divide by 6, done. So basically what I did is I made something that wasn't real in the first place. That's what this means when we say an extraneous solution. You create something that isn't really possible. So unfortunately, when we're doing square roots, we have to be aware that we could actually make an answer that's not real. Will you go answer that? Okay. So every time you get a square root problem, you're going to have to check your answer. Why are you all staring at her answering the phone? Okay.
Yeah. Wait. Okay, thanks. Bye. Don't ask me to do that again.
I answered when I can do it.
All right. So here's the last one we're going to take a look at. And then we're done. I was just trying to not have that go across this recording, but
No, he's like.
you made it painful anyways.
No, he's like. Can I talk to Mr. Coughlin?
Who was it?
It was Hirschman. And he's like, can I ask who I'm speaking to? He's like, yeah.
All right. So last one and we're done. Last one. Are you ready to square both sides of this equation? What's up? Oh, I'm sorry. Yes, you're absolutely right. The answer we came up with was not allowed to be possible. So in this situation, sorry, we got sidetracked. There is not a possibility there. All right? That's a great question. Thank you, Quinn. Am I ready to remove the square root? Well, there's nothing else over there, so can I get rid of it? I can. Okay. This problem though, it presents a different type of a problem. What's up?
So when you square it, you just cancel it and then give it equal to 0?
Which one? This one?
Yeah.
That's what I'm going to end up doing. Because this is the first problem where my other side of the equation isn't a number. Now there's a variable there. And so when I square this one, I end up with y squared is equal to 2y plus 3. When you have a power greater than 1, and in this case you have a power of 2, you've now created a quadratic. Yeah, what we've just been looking at. So it's going to create a picture that's either like a U-shaped graph, a parabola, or it's going to be an upside down U-shaped graph. You know what I'm talking about? Any equation that looks like this, you solve it by moving everything to one side. You got to force it to be equal to 0. That's how you have to solve a quadratic. You push everything to one side. Because there's no like terms here. So there's no like moving my variables to one side and my constants to the other. That's not an option. If you move something from one side of an equation to another, what happens to its sign? It just becomes the opposite. Okay. So I think for the sake of this, it's probably easier if we just move everything to join the y squared. So we end up with an equation that looks like y squared minus 2y minus 3 is equal to 0. Okay. There's 3 choices here. We can factor it. We can use the quadratic formula, or we can graph it. Okay. This idea right here is going to be all over your state test next week. Quadratic equations, I promise you. We can graph it, we can factor it, we can use the quadratic formula. I got a feeling I know which one you're going to say.
I have a question.
Okay, what's up?
How do we, you said it's going to be on the state test.
Uh-huh.
Can we graph it?
Absolutely.
We can.
Yes, Desmos is a part of your state test.
Oh.
That's why we use it. All right. So which way do you want to go? Fine. If you want to graph it, 2 things. Number 1, obviously you got to get your computer out so you can graph it. So you're going to have to open it up or open up somebody's near you and just look off theirs. Number 2, you cannot, hear me as you're doing this, you cannot graph an equation that has a variable of y, like the y's in it like that. You're going to have to change those out. What are you going to change them out to? Just change them to x's. So instead of y squared minus 2y minus 3, it's going to say x squared minus 2x minus 3. Because when you go to graph, it's expecting it to be in x's, and if you graph it in y's, it's not going to know. It's going to get all goofy. So you either need to be looking at someone else's graph screen right now, or you need to have one on your own. But sitting there with nothing's not going to do it. What'd you do? By factoring? That's what I would have done. Yeah, it's much quicker. But if you don't remember how to factor, it's not.
I did for a while and then I
Stopped for a second, thought about it. Okay. Okay, so if I graph this, now remember, you are changing this out. Instead of y squared, be x squared minus 2x minus 3. You do not need the equal 0. If you put the equal 0, your parabola goes into 2 vertical lines. Now, it is the same. Absolutely. It is still going to cross at these 2 values. So there's answer number 1, and there's answer number 2. Okay? So if you put the equal 0, it will still go through there, but it will be 2 vertical lines that go straight through those 2 values. I think the equal 0 part kind of weirds some of us out because all of a sudden what I expected to see is not what I see. And I see these, I feel like I did something wrong. So my suggestion would be you just leave the equal 0 part out. All right. Now, this problem has how many answers? Right now, it has 2 answers. I have to do what with those 2 answers? Not that I need to solve. I've solved. I have an answer. I believe x to be equal to -1, and I believe x to be equal to 3, or y in this case. So right now it looks like this is my answer. But I need to do what with those answers? I got to plug them in and make sure they work. If they work, I'll keep them. If they don't, I'll cancel them out. If I cancel both of them out, I have no solution. If I cancel one of them out, I just have one solution. If they both work, I got 2 solutions. That's about that straightforward. You just got what? A? Yeah. If you put a -1 in here, what's 2 times -1? Add 3 more. 1. What's the square root of 1? but it's supposed to be -1. So this answer doesn't work, which means that answer doesn't work. Go away. If you put a 3 in there, 2 times 3 is 6. Add 3 more. Square root of 9. That one works. So it's that answer.
A, but that's not.
Well, it was one. Remember, when we came over here,
Oh, you don't have to use both.
correct. Well, we don't know. Maybe we use both of them. Maybe we use one of them. Maybe neither of them work, right? The point is, when you are looking at radical equations, you have to make sure that you check your work. That's like 6 questions. All right. Plug them in and see which one works. All right.